All right, we're going to take a look here today. A couple things. First off, some highlights from right triangle trig. So using right triangle trig just simply means that we're going to have a right triangle, which means things that come into play would be Pythagorean theorem, SOHCAHTOA, our acronym for sine, cosine, tangent, and finding those different trig values and or sides or angles of the right triangle. So it's using those two main properties, SOHCAHTOA and Pythagorean theorem, inside a right triangle to determine sides and angles or trig values of that particular triangle. Right? So let's look at something like this. Let's say I have a triangle here. Again, we're doing a right triangle. I'm going to call this A, B, C. I'm going to say that's 5 and that's 6. Now, first off, when we're quickly drawing right triangles and looking at some different representations, nothing's necessarily drawn to scale. So, if one side looks longer than the other and I said it was shorter, it doesn't really matter. Just go by the representation of the length. Okay? So, let's say we want to find the 6 trig functions of angle A. So I want sine A, cosine A, tangent A, cosecant A, secant A, cotangent A. I want to be able to find those 6 trig functions. And anytime I'm asked for the 6 trig functions, my focus needs to be on these 3 right here. Because what I realize is these are the reciprocals. So in other words, if I can figure out sine, I can do the reciprocal value and get cosecant. If I can figure out cosine, I can do the reciprocal value and get secant. So my focus is right here on this side. All right, I'm asked for sine of A. Sine, opposite over hypotenuse. So I look right here at A. Opposite is 5. Hypotenuse is missing, so I need that value. I do need that value. I'll just put a question mark there for now. But once I know that, my answer is going to be 5 over whatever that value is for the question mark there. So sometimes I'm looking at a triangle where, a right triangle anyway, where I have 2 sides and missing that third side. In comes that Pythagorean theorem. So what I know is that question mark squared equals 5 squared plus 6 squared. Let's see, that's 36 and 25 is 61. And so that would be root 61. Now, what we're going to focus on right now is what we call exact values. Exact values mean no decimals. So yes, I know I can go to my calculator and get a decimal value for that root 61, but if I'm asked for an exact value, what I want to do is leave it as root 61. That's going to be the exact value of it. So sine, opposite 5 over hypotenuse. I have 5 over root 61. Cosine, adjacent 6 over hypotenuse, 6 over root 61. And tangent, opposite over adjacent, 5 over 6. One of the things that I typically focus on, if you ever get confused about which one's opposite, which one's adjacent, I always find the hypotenuse first. So this guy is the hypotenuse, which means it's never going to be considered the opposite or the adjacent. So once I know this is the hypotenuse, then I'm looking right at it. Hey, there's the opposite across from. Here's the adjacent next to. I've already got this identified as the hypotenuse. Cosecant, secant, cotangent are reciprocal functions. Since I know the sine is 5 over root 61, the cosecant is root 61 over 5. Cosine 6 over root 61. So secant, root 61 over 6. And tangent being 5 over 6, cotangent would be 6 over 5. There's those reciprocal values. I think it's easier to remember in the beginning which one is the reciprocal of which versus trying to memorize all the different things that are going to be coming with cosecant, secant, and cotangent. If I can relate them back to the original, meaning that I know if I'm asked for one of these, if I go find this first, then I can get that. It can help me kind of get things tied together, and then these guys will come a lot easier later on as we're doing more with them. The other thing I'm going to add in here, there is nothing wrong with these answers, but sometimes you may be asked to rationalize denominators. That would make this one 5 root 61 over 61, and this one 6 root 61 over 61. Now, rationalizing a denominator. It is not always required. I like to think of it, if I'm asked to do it, I will. If I'm not, I'll leave it like this. I don't mind those answers. Just kind of depends on what I'm asked to do. In a lot of areas of trig, we do like to see these rationalized just because it goes back to our more algebraic times when we didn't like radicals in the denominator. But of course, either one would technically be correct. Just a reminder, if you forgot how to rationalize, I'm looking at this guy right here, and I'm going, all right, if I want to get rid of that radical, I'm multiplying both numerator and denominator by that root 61. So this would give me 5 root 61, and root 61 times 61 is just 61. Let's get another example similar to this guy right here. Let me get a different triangle here. Go with 12, 13, call that B, that A, there's C, my right angle. And this time we'll find still the 6 trig functions, but we're going to go the 6 trig functions of angle B. 6 trig functions of angle B. I'm going to say sine B, cosine B, tangent B, cosecant B, secant B, cotangent B. I'll just go ahead and get them all written out since we wanted all 6. Those pieces there. And I'm missing a side again. So I can see I'm missing this side. So I need that piece there. This time, instead of putting a question mark, I'll just call it X. Okay? Doesn't matter what we have there, but we need that side. I need to know what that piece is going to be. Okay? So I think for a minute, what I said earlier was I always like to find my hypotenuse first. Find my hypotenuse first. And in this case, the hypotenuse would be 13. I like to find that guy first. That means here's my 2 legs. So when I set up my Pythagorean theorem, I would have x squared plus 12 squared is 13 squared. So 13 squared is 169. 12 squared is 144. Let's subtract that over, and I get x squared is 25, which means now x is 5. I know that's going to be my missing side. Now that I have my 3 sides of the triangle, I can go through and find my 6 trig functions. So again, here's my hypotenuse. Sine. Opposite over hypotenuse. So remember, opposite and adjacent are according to what you're looking at. So if I'm looking at B, since I'm asked for sine of B, opposite is 12. That's the one across from B. So opposite over hypotenuse, 12/13. Cosine of B. Adjacent, the one next to B, is 5. So adjacent's 5 over hypotenuse, 5/13. And then tangent opposite over adjacent, 12 over 5. And now I've got those three base ones. I can go over and get my other cosecant, secant, cotangent ones piece. So cosecant, 13 over 12. Secant, 13 over 5. Cotangent, 5 over 12. And again, I'm just remembering which one each is the reciprocal of. Cotangent is the reciprocal of tangent. Secant, the reciprocal of cosine. Cosecant, the reciprocal of sine. Let's change it a little bit here. Let's say I give a triangle. Let's do something like this. A right triangle there. I'm going to call that A, B, C. I'll put a 15 there on the hypotenuse. 52 degrees at angle A. And we got side A, side B. Now, when we draw out our triangles, one of the things that we want to remember is sides and angles kind of match up. So notice I've got side A across from angle A, side B across from angle B. Now I'm given a diagram here, but if I was told, hey, side A is 5 and angle A is 52 degrees. Well, when I draw it out, I want to make sure A is across from A, B is across from B. Now it doesn't matter what the letters are. If I called this angle M, then that would be side M. Now if I called this angle X, well, that would be side X. So just stay in relationship that way. So what we're going to do here, I'm going to say find missing sides slash angles. So we're going to find whatever's missing between our sides and angles. So I can look up at my diagram and I can tell, all right, I need side A, I need side B. I don't have those two. And I need that angle B. I have angle A at 52. C, I see the box, that's my right angle, so I already know that's 90 degrees. And I've got side C, or the hypotenuse, at 15, so I'm looking for these three missing pieces. This is still involving our right triangle trig because it's still involving our Pythagorean theorem, SOHCAHTOA, anything with regards to that right triangle. One of the things that I do want to remember about a triangle from my past is that all three angles have to add up to 180 degrees. So since all three angles have to add to 180, I can take 90 and 52, and that's 142. Subtract that from 180. Make sure you get the right number here, 38 degrees. So B would be a 38-degree angle. And again, remember, I'm not worried about something drawn to scale. I've got just a generic triangle here. I know these two look pretty close to the same size, but I'm just working off what I'm given. I've just got a generic triangle. Side A, side B. Well, I'm going to go for side A first. And I'm only going for side A first because I wrote it down first. It's not because I think A is easier than B. I need to find both of them. So I'm just going to go for A first. I'm going to look at what I'm given. I always like to use what I'm given and rather than something I found, because if I made a mistake in something that I found, I'm carrying that forward. So in other words, I don't want to use the 38 degree because what if I was wrong there? What if it was 28? I put a wrong number in my calculator, just subtracted in my head wrong, whatever. I want to go off of what I'm given. So I'm given that 52 degrees. I want side A, and I'm given 15. 52. I want the opposite. I'm given the hypotenuse. So I'm thinking of my trig functions. Would sine, cosine, or tangent represent that? I'm given hypotenuse, I want the opposite, that would be a sine. So here's my equation. Sine of 52 degrees is a over 15. There's my setup. I know that my sine function is going to be sine of 52 degrees, a over 15. I can multiply both sides by 15. So 15 sine 52 degrees is a. Okay. Now I can use my calculator. So 15 sine 52. And I've got a as being, I'll just go nearest tenth, 11.8. I had 11.82016. I'll just say 11.8. Make sure your calculator's in degree mode. Right? You have a degree and a radian mode. Make sure it's in degree mode since I have degrees here. Now for B. B is the adjacent hypotenuse. That's a cosine. Cosine 52 degrees is B over 15. Adjacent over hypotenuse. So multiply that 15 over. 15 cosine 52 degrees is B. Then I can go to my calculator. And again, I'll go nearest tenth, 9.2. Now, one of the thought processes, and it's not an incorrect thought process, is, hey, you know what? I had A. Why can't I use Pythagorean theorem now? I certainly could. There's two things that are reasons why I don't. Number one, what if I got this wrong? I'd rather go back to what I'm given, the 52 degrees and the 15, work with that, then I'm not using the possibility of an answer that I had gotten wrong. Secondly, I need to remember that I did round off this number. So if I would like to use Pythagorean theorem, well, I need to carry out these decimal places because this wasn't really 11.8. I don't remember exactly what it was. It was 11.82016, something like that. But it wasn't exactly 11.8. That could throw off this guy a little bit. So that's why I like to go back and use what I'm given. Right? But I don't want you to think, hey, it's wrong to use Pythagorean theorem. I think, yes, it's just fine to use that. But a couple of pitfalls would be, I need to make sure I have the whole value here, and I'm counting on the fact that I didn't make a mistake, and we all make mistakes from time to time, so that's the reason I go back to what I was given. Right. Let's look at the same idea, different triangle. So we're going to find the missing sides and angles again. I'm just going to create a different triangle here. Let's see, we'll go at 21. There. I'll say a 25 degree there. A, B, and again, C is my right triangle. So that would make this side A, this side C. So remember, A is across from A, B from B, C to C. So we're still going to be finding our missing sides and angles. So in this case, I'll just list them out like I did before. I want angle B, I want side A, I want side C. It doesn't matter which one I find first, I've got to find all three. Typically, if I only have one angle to find, I like finding the angle first, just because I know they add up to 180. So I can go 90 plus my 25. 90 plus 25 is 115. Subtract, that'll leave me 65 degrees for angle B. Now A and C. I'm going to go again A first just because I wrote it first, no other reason. So I'm looking at what I'm given. I'm given a 25 degree. A's relationship to that 25 degrees is opposite. The other side I'm given is 21. 21's relationship is adjacent. So I have opposite A, adjacent 21, that's TOA, that's tangent. So tangent 25 degrees is A over 21. My tangent value. Multiply both sides by the 21. 21 tangent 25 degrees is A. And again, just for the sake of the lesson and staying consistent with before, I'll just go to the nearest tenth. I actually got 9.79246, so on and so forth. I'll just round it off to that 9.8. And then C. All right. Again, I'm going back to what I was given. So I've got 25. C is the hypotenuse. 21 is the adjacent. So I've got 20. I'm looking at 25. Adjacent, hypotenuse. That's cosine. Cosine 25 degrees equals 21 over C. Now that variable's on the bottom. If I multiply both sides by C, I get C cosine 25 is 21. And so then divide over the cosine. C is 21 over the cosine of 25 degrees. Let's see, 21 divided by cosine 25. And again, I'll go to the nearest tenth. I got 23.2. I had 23.1709 and so on for what I got on my calculator. I just went nearest tenth there. Now my values, they do make sense. I mean, this is the hypotenuse. It should be the longest side. 23 is definitely the longest side. 21. We can even see that back in this guy. 15 is my hypotenuse, should be the longest side, and the other two are smaller. Another thing that can help us with, as far as just kind of doing a quick check, did I get my values right? It's not going to tell you if the exact values are right, but you know you're in the general area of being correct. The largest angle is always across from the largest side. Smallest angles across from the smallest side. So on a right triangle, the hypotenuse is the largest side, and because that's the largest angle, 90 degrees. Well, in this case, the smallest angle is 38, and that's also the smallest side, 9.2. 90. C is 23 or 23.2. Hey, smallest angle is 25, and side A is 9. It's the smallest side. So I do have that in the medium across from the medium, or middle, I should say. Middle angle, middle side. All right. So, right triangle trig. What does that mean I'm using? Pythagorean theorem, SOHCAHTOA. Those are my two primary things dealing with right triangle trig. I can find trig values. I can also find missing sides, missing angles, things like that using those ideas. Now, 7.1. 7.1 deals with graphs of sine and cosine functions. So, a few highlights from that lesson we want to make sure that we know. Number one, when I'm asked to graph a sine function, here's what I remember. It looks something like that. It's going to start going up, come back. This right here is what we call a midline. What's the middle? That's called a midline right there. See, the middle of the graph breaks it in half. Cosine looks like this. Similar to kind of like a parabola we've graphed before. It's not really a parabola. We kind of visualize that a little bit. We've seen that. This has a midline right in the middle going right through. There's the midline kind of cutting it in half. Now, our focus is typically going to be graphing one period of these things. So there's one period of the graph that was discussed in the lesson. They keep going forever, but the idea is, hey, if I can graph one period, well, I can graph 3 periods, because if I can do one, I'm just going to repeat the same thing 2 more times. I can graph 3 of them. So focus will be off of one period. Standard period for a sine and cosine is 2 pi. Standard period. So graphs can be compressed, stretched, things like that. That does change the period, but the standard period would be that 2 pi. And we have a standard form looking something like this. And I can put the right letters in. Something like that. Now, it really doesn't matter what the letters are, just get in different places. I put sine or cosine because it's a standard form for both. So what we want to remember is this guy out front is the amplitude. D is what we call the vertical shift. So what moves the graph up and down. And right here, C over B is what we call a horizontal shift. And together, we call the horizontal and vertical shift a phase shift. That's just how it was moved. Sometimes we're asked for a phase shift and we'll put them both together. Hey, it went this way, right, left or right, and it went this way, up or down. And sometimes we separate them and call them a horizontal or a vertical shift. You'll generally hear me say just phase shift, kind of describing both of them. So let's look at some variations here from the lesson. I'm going to say for this particular, we're not going to graph yet. I'm just going to say find amplitude, period, and the phase shift. We're going to find amplitude, period, phase shift. Now, a lot of the examples that were in the lesson and so forth had pi sitting in here. So we're going to graph some with some pi's in it. I just want to put a couple of examples up here for amplitude, period, phase shift with just numerical values to make sure we're just looking in the right spot to find these pieces. So the first one, y equals 3 cosine 2x minus 8 plus 1. Now, I don't really care if this said cosine or sine. It's still going to be the same amplitude, period, phase shift. So amplitude, how tall the graph is. In this case, I'll just call this number 1. Amplitude is 3. Period. Period is 2 pi over 2. It's 2 pi over that b value. So the standard period is 2 pi. I'm dividing it by 2, so this thing's being compressed some. It's being brought in. So 2 pi over the b value, which in this case would just be pi. I can reduce that. Sometimes I can reduce them, sometimes I can't. The phase shift, we're going to go up 1. That'd be the vertical shift. There, that plus on the outside. And we're going to go right 8 over 2. So the minus, I'm going to move right. It's the same as the old transformations. If we're going to go right, I see the minus. Left, I would see the plus. And this time, C over B. So 8 over 2. And we can, of course, just rewrite that as right 4 units because I can reduce the 8 over 2. That's fine. Second one. I've got y equals negative 2 sine 5x plus 3 plus 4. Amplitude 2. So the negative from our lesson flips the graph upside down. 2 is the amplitude, so it's at 2 units tall. Period. Two pi over that coefficient b, 2 pi over 5. Phase shift. Let's see, phase shift, we're going to go up 4. See that plus 4 on the outside. And we're going to go left this time. Plus is going to move it left. So we're going to go left 3/5. Left 3/5. C over that b value. And then a third one here, and then we'll look at a few graphs. Sometimes we'll see something that looks like this. 4 sine 3, then another set of parentheses, and minus 5. Sometimes we'll kind of see that double set of parentheses with that 3 kind of being factored out. For example, I could factor a 2 out of this guy right here. If that happens, there's nothing wrong with it. It's nothing wrong with that look. What usually gets us is it doesn't look like what we're used to. So here's what I like to do. I'll just go ahead and distribute the 3 back through. Oh, that was. So I have 3x minus 6 and minus 5. And then it's back looking like the others. Getting it back to that similar form. My amplitude is 4. My period, 2 pi over 3. Phase shift, down 5 because I had the minus 5. And we're going to go right 6 over 3, C over B, or that would just be a right 2. And this is why sometimes they'll see it factored out. Because now you can see that right 2 sitting right in there. There's the period piece, or the part that's affecting the period being factored out. But if you're used to looking at everything else with it in there, then it might be easier just to distribute that and it looks like the rest of them. All right, let's look at a few graphs here. Now, on a graph, before I do any kind of sketching, I do want to know what my amplitude, period, phase shift is for the graph. I need to find those pieces. So just like I was doing there, I should be able to look at the function and tell what the amplitude, period, and phase shift is. All right, we'll do something like that. Okay. 3 cosine 1/2 x minus 1. Again, first thing I want to do, amplitude, period, phase shift. Amplitude, 3. Period, 2 pi over the coefficient, which is 1/2, which is actually 4 pi. Phase shift. Down 1. I don't have a left or right movement this time. I just have a down 1. You'll see that minus on the outside there. I don't have any plus or minus in here, so it wasn't moved left or right. Another thing that's nice to have when you're finding amplitude, period, phase shifts, and you're asked to sketch, once I know it's a cosine, I like to do a little diagram, just reminding me, hey, you know what? There's what you're graphing. I'm graphing something like that. Doesn't need to be perfect, just reminds me this is the sketch I'm graphing. Right. Now I'm going to graph one period. My goal is to graph one period. Well, the period's 4 pi. So what I like to do is kind of set up what I'm going to be drawing. The period is on the x-axis because that's what, if this was a 2 period, if that's 2, then that's 4. If that's 2, then that's 1. And it's going to stretch it back and forth. So that would be along the x-axis. Well, if the period's 4 pi, that means I'm going to start at 0 and I'm going to end at 4 pi. If my amplitude is 3, I like to list a y min and a y max. So that means this lowest y value right here is going to be -3, and the highest up top here is going to be a +3, because the amplitude was 3, meaning the total distance was 6, 3 above and below that midline. Then I'll account for the phase shift. This particular phase shift went down 1. Since it goes down 1, the phase shift is only affecting the y's. This is the up-down. Remember, this is left-right. So if it's going to go down 1, the -3 will go to -4. The 3 will go to 2. I just moved each one down 1. And I don't like to erase these guys. It reminds me what I originally had and what I did here when I'm looking back at my work. Now I'm really set up to draw it. I'm going to go from 0 to 4 pi. So I'm just going to count by pi's. Pi, 2 pi, 3 pi, 4 pi. I'm going to go up to 2. 1, 2. I'm going to go down to -4. Down a little further. There's my -4. This has allowed me to set up where my graph's going to be. Now, there's my shape. So at 0, I'm going to be starting up there at the top, which would be at 2, which means at 4 pi, I'm going to be back up here at 2. Halfway in between, I'm going to be down here at the bottom. So at 2 pi, I've got to be down here at -4. And now I can do my sketch. Doesn't have to be the most perfect graph, but that's what I was drawing there. So this is allowing me to see what I'm drawing. These 3 guys are helping me set this up, and then I can go through and work my sketch. How about, let's go with this guy. Let's go y equals -3 sine of 2x plus pi. There's my function. I'm going to start out the same way. I want my shape, my amplitude, my period, my phase shift. Shape will look like this. Notice the negative, it flips the sign over. So I'm going down first. Amplitude, 3. Period, 2 pi over 2, which is just pi. So I've got a period of a pi. Phase shift. Phase shift left, I can spell left, pi over 2. Left because of the plus, c over b, that pi over 2. And I'm not going up or down this time. I don't see anything on the outside right there. All right. I've got my pieces. I know what it's going to look like. I'm going to go set this guy up now. Once I set this up, then I can go to my graph. So I'm going to say an x min, x max, y min, y max. So I'm trying to set, where's it going to start? How far is it going to go this way? How far down is it going to go? How far up it's going to go? That's my goal here. So, period sets the x's. Period was pi. So 0, pi. Always starting at 0. Amplitude is 3. So -3, 3. Amplitude. Now I'll bring in the phase shift. This had a phase shift of left pi halves. If the graph moves left, that's not going to affect the y values. It's affecting the x because it's shifting the graph to the left. So if I'm at 0 and I go left pi halves, I'm going to go to negative pi halves. If I'm at pi and I move left pi halves, I'm going to go to pi halves. So think of it as 0 minus pi halves, pi minus pi halves. I'm shifting that graph left. Now I have the basic coordinates to set up my grid. I'll draw my axis. I'm going to be left pi halves, so negative pi halves. I'm going to end at pi halves. I'll just put that over here, pi halves. -3 to 3. So 1, 2, 3 on the y. -3 on the y down there. And now I'm going to look at this. This is what I'm drawing. So there's my midline. I'm going to start right here. I'm going to go down, come back. I'm going to end up back at that middle point. Notice this point, this point, this point, all on the same level. So I'm going to be coming back through here. Look at that origin. All right, I'm going down first because the negative. So down to -3. Come back up. And +3 and turn and come back down. There's my one full period. It's not really crossing at 1. It's crossing here at the origin, coming through. I kind of drew it kind of close there, but you get the idea. And there's my sine graph, or my negative sine graph, I should say. This, let's go y equals 2 sine x minus pi plus 1. So once again, same thing. I want shape, and then I want amplitude, period, phase shift. Shape. Back. Positive sign this time. Amplitude, 2. Period, 2 pi. My coefficient's a 1 here, so it's not changing from the 2 pi. Phase shift, up 1. Right pi halves. So up 1, there's my plus. Right from the minus, c over b, pi over, not pi half. Why did I do that? It's just right pi. Pi over 1. Just right pi there. So my next step, I'm going to set up my x's and y's, meaning my x min, x max, y min, y max, x min, x max, y min, y max. Period sets my x's, 0, 2 pi. Amplitude my y's, -2 to 2. I always want those. You notice each time I set those first, then I go apply the phase shift. I want those set first. Now I go to the phase. This thing went up 1. So that means instead of -2, it's at -1. Instead of 2, it's at 3. moved it up 1 unit on the y's in each case. Right pi, so instead of 0, it's at pi, right pi units. Instead of 2 pi, it's at 3 pi. So I added pi to both the min and the max since it moved to the right. Now I set it up. So I'm just going to count by pi's. So I've got pi. I'm just going to make my graph a little bit bigger here. I'm just going to go pi, 2 pi, 3 pi. And let's see, a -1, 1, 2, 3. And now I'm going to graph my sine. All right. One of the things, again, to remember about the sine, it starts, ends, and in the middle at the same level. And that's what we call the midline. So when I'm looking at this one, the midline is halfway through the graph. Okay? This midline was at the axis 0 because it went from -3 up to 3. This one got shifted up 1. It's all right. If there's -1, 1, 3, here's the midline at 1. That's halfway through. So that means that this graph at pi is going to start there at 1. At the end, 3 pi, it's going to end at 1. In the middle, it's coming back to 1. So my graph is going to leave this point, go up to 3, come back through, go down to -1 because that's the lowest value. And last time I just kind of drew the curve. If it helps you, you can go right in here in the middle here, just come up and go, all right, that's going to go to 3. Give me some points to help me. Right in the middle here, that's going to come to -1. You like to have the extra points. And there's my sketch. I like to have, I know the first one was a cosine, I erased that, but I like to have my little sketch here, what it's supposed to look like when I'm identifying this stuff. Just because I found this, I'm already setting all this up. I draw my axis, get it based on this. I don't want to go back and, wait, what in the world am I drawing again? I got my little diagram there that tells me exactly what I'm drawing and what it's supposed to look like. I can just glance right back here, go, all right, start there, go up. This one started, went down first. The first one we did the cosine, and then it went down and then back up. It just helps me kind of visualize what I'm doing as I'm moving along, and especially when I'm kind of starting to plot a couple of points in there. It does help. Simple task to add this thing in. If you're ever asked to sketch, you're typically not asked for amplitude, period, and phase shift. Pretty tough to sketch them if I don't know what they are. So I think the best thing to do is list them out. Then go set up your beginning, left beginning, right ending, how low, how high it's going. If they change because of the phase shift, what you've seen me do, video and now, is I like to draw a line through and just put it. Because then when I look back at what I've done, my notes, my practice, anything I've done, my homework, whatever, like, all right, it was originally 0 to 2 pi because of the period. Why did I change it? Oh, it went right pi. There's what affected that change. Why didn't these two change at all? Well, I didn't have anything that moved the graph up or down. So I didn't change that part. So I think it's nice to have in there. It does kind of help out. Okay. That gives us a few more extra highlights with regards to the graphs and with regards to the right triangle trig that we started this particular video with. So hopefully that helps you out going forward.